Jai Hind everyone, myself Sandeep Yadav, Assistant Professor CSE Department. So today I am going to deliver a lecture on concurrency control technique, which is part of the curriculum of subject Dbms being taught in AKTU to different students, either studying in 5th semester or 6th semester or MC students. So as you know, concurrency is the ability of the system to execute several tasks or processes or events at same moment of time. So there is a greater chance of conflict between them. How to resolve that conflict? We have certain techniques. Those techniques are known as concurrency control technique. Let us see the outline of the topics that I am going to discuss today. First, I am going to discuss about concurrency, then various problems that are associated with the concurrency. Thereafter, we shall be discussing some of the technique used: blocking, two-phase locking, time stamping protocol, and deadlock. Concurrency is the ability of the database to allow multiple means more than one users to access the data at same moment of time. So since we are accessing the data at same moment of time, there are bound to be some problems. So we are going to discuss only 3 problems today. Number 1 is lost update problem, number 2 is dirty read, and number 3 is incorrect retrieval problem. So let us discuss each of one by one. Lost update problem. This problem indicates that if two transitions here T1 there is a transition T1 and there is a transition T2. So what is happening is transition T1 is reading a value of X, and thereafter transition T2 is reading a value of X. Now T1 is updating the value of X and T3 is updating, T1 is updating the value of X and T2 is updating the value of X. Now we are seeing that the update done by T1, that is the update done by the T1, has been overwritten by the update done by the T2. That is, both of the transition has read the same value. Here also T1 is reading same value and T2 is reading same value, because there is no read operation in between T1 and no write operation between read operation of T1 and read operation of T2. So though both of them are reading a same value. Now thereafter the reading of X by T2, T1 update the value and thereafter T2 update the value. There is again no read in between them. That is, this means that the update done by T1 has been lost and the update done by T2 will prevail. So how to avoid this problem is the transition T2 should not update the value of X until transition T1 can commit the data item. See, the problem occurring is that T2 should not be updating the data until the transition T1 commits its value. Because it does not commit the value, therefore the changes are not made permanently in the disk. Hence, we lost the update done by the T1. So next is the read problem, dirty read problem. Here we are seeing that there are two transitions T1 and T2, and T2 is updating the value of X. Thereafter T1 is reading the value of X. Now T1 is reading a value of X that is done by T2. Now after some time the T2 fails. So what happens is that the value that is read by T1 is a value that is a false value, that is a dirty value, since T2 fails. So the value that T2 return should not be read by T1. So what will happen? The dirty read problem will occur. So as already written here, that when transaction update some value and that it fails due to some reason, this updated value is retrieved by the transaction before it is changed back to the original value. Means T1 is reading a value of T2 that has become inconsistent due to the failure of T2. So what should have been done is that first the T2 should have committed its value, only then T1 should have read it. Then this problem would have been resolved. So let us see how a T2 must not read the data item unless T1 should not read a particular data item unless T2 commits that particular value of data item X. Now, what is the data item X? We have been discussing. X can be any field, any tuple, or we can say row, or record, or file, or entire database. So what constitutes a data item? It can be anything, either field, tuple or row, record, file, entire database or entire table. So X can be anything. Now X should be selected in such a way that its value should not be either too small or too large, because both of them leads to different problems. Now first concurrency technique is locking. So locking is a technique that is used in concurrency control to overcome the various problems that we have just used. Now let us see how it is done. Now initially there are 4 users here. Now log variable is initially 0 because none of them is using. Now T1, this user wants to read a value, therefore it will apply for the log. So it will be able to do the, since it is applied log and has been granted log, so it will be able to read the value of database. Now T2, this user want to read the value, but this user cannot read the value since the first user has already having the log on this particular data item. So other the user is not able to access that data item since it is already held in particular locking mode by this user, by the transaction executed by this particular user, and further 2 users will also not be able to access that data item. So locking is a strategy that is used to prevent concurrent access of data to multiple users so that the problems do not occur. Now let us discuss this protocol in detail. So data item can be locked in 2 modes by the transaction, either shared mode, in share, or exclusive mode. That shared mode is denoted by S and exclusive mode is denoted by X, and shared mode is denoted by S. So what is shared mode and what is exclusive mode is, in shared lock a transaction can only read the value, it cannot write the value, and in exclusive mode a transaction can read as well as write the value of a particular data item. So if in particular moment of time, if a transaction is reading a value of data item, then if another transaction want to write that value, should we permit him? No, we should not permit him, because the value is already read by a transaction. So other transactions should not be allowed to modify it, because otherwise the user one which has applied read lock on it may be seeing certain different values than the initial values that he is supposed to see. So based on that, there is a log compatibility matrix which shows all the possible number of combinations that occurs while using shared and exclusive log. Let us see them one by one. So there are this is the log held by transaction T1, those are depicted here, and these are the logs that will be held by transaction T2. So we are seeing that a transaction T1 has applied a shared log, then another transaction T2 also want to shared log on the data item already read by this one T1. So one transaction is having already the read log, that is shared log, and another transaction also wants the shared log. So there is no conflict here, as we have already studied in conflict serializability. There is no chance of conflict between the transactions if both the operation performed are read operations. So there will no issue, the value will be yes or true, means it will be compatible or it will be true. Now second is, if the transaction T1 has already having the exclusive lock and another transaction T2 wants a shared lock, should we allow him? We need to ponder over these situations. Well, we should not allow this because T1 is writing a value of data item X. So if we permit T2 to read that particular value, he may not be reading a consistent value because the value is in transit. Either it will be a intermediate values or maybe some other values. So we cannot allow that to happen. So that will be no or not compatible or false. These are all the same. Next, if transaction T2 has a lock and T1 wants a lock, then should we allow? We will see the matrix again. See, if it has a shared lock and this one shared lock, then we can, this has an exclusive lock, T2 has an exclusive lock and T1 wants the shared lock. So again we will not be allowing this, so this will not be happening. And again T2 has an exclusive lock and T1 also wants exclusive lock, we will not be allowing these methods here. So if a lock may be granted only by the lock manager, provided there is no conflict or the data item is currently free. So there are two methods by which the lock can be granted. Either resource is free or resource is not held in conflict mode. Only then the lock shall be permitted, otherwise the permission shall be denied. So any number of transactions can hold a shared lock on any data item. Suppose T1 has a shared lock on data item X and another 10 transaction want a read operation, they can get the permission because reading a value does not change the value of the data item. So any number of read operations can be allowed if a particular data item is having only the shared lock. But if it holds an exclusive lock, no other transactions will be given the permission to access that particular lock. Now let us see some more things about this protocol. This locking protocol divides the transaction into three parts. When the transaction starts executing, it creates a list of data items they need and request for all the locks it needs. See, this is the where the transaction acquires all the lock and no other lock is required, transaction keeps executing its lock. So first phase is the lock acquisition phase, which starts as soon as the transaction starts working. Now as soon as the transaction finishes its works, that it is executing from here to here. From this point, transaction begin to transaction end, the lock is present on the data item, and this phase is known as execution phase. As soon as the transaction releases its first lock, the third phase starts. In this phase, the transaction cannot demand for any lock, but it only releases the required lock as soon as its requirement ceases. So towards the end, there is lock releasing phase, whereby a transaction release the data item which do not require currently. Now this protocol is not deadlock free, so we are seeing a variant of logging protocol, that is two-phase logging protocol, which is quite useful, and as the name suggests, it works in two phases. First phase is known as growing phase, and let us see what is growing phase. Now, as illustrated in this diagram, that towards the beginning of the transition, it enters the growing phase. That is, here the transitions obtain the lock, but it cannot release any lock. So this phase is towards the beginning of the transition, whereby they obtain the lock, but they cannot release any lock. Now, when a transition has takes the final lock, then it is known as lock point. Lock point is the point after which no further locks will be given permission by the lock manager. Then that will be the final lock. Now, second phase is shrinking phase, which is towards the end of the transition. In shrinking phase, what happens is that a transition will release the lock, but it cannot obtain any new locks. So in this phase, only locks will be released, but no new lock will be acquired. And so this phase is towards the end of the transition. Now, this is drastically different to the simple logging protocol, whereby there was some unlocking can be done in the mid also, in the transit also, and thereafter another lock can be acquired. But here, unlocking shall be delayed. Unlocking shall be done after the end. Now, strict two-phase locking versus rigorous two-phase locking. Well, there are two main variants of the two-phase locking. One is strict two-phase locking, another is rigorous two-phase locking. These techniques are used to avoid the cascading failure, which is a big problem. See, the cascading failure is a type of failure which occurs when a failure of a single transition results in the failure of multiple transitions. We can say that a cascading failure is occurring. So, to avoid them, we can use either strict two-phase locking or rigorous two-phase locking, depending on the requirements. Well, we will be first discussing the two-phase locking. So, in this protocol, a transition may release all the shared locks after the lock point has been reached. See, after the lock point has been released, it can release all the shared locks, but it cannot release any of the exclusive locks until the transition commits or abort. See, the advantage is that even if we release the shared lock and if the transition fails, then since the exclusive lock have been not freed, so other transition will not be able to get the lock on those data items, and they will not be able to read the dirty value or do any update that is not desired. It ensures that even if the data is modified by the transition, then other transition cannot read it until the first transition commit it. That is the main crux of this protocol. This protocol solves the dirty read problem that I was telling you earlier. Now, next is a little bit more tightened situations in rigorous two-phase locking, whereby a transition cannot release any type of lock, whether it is shared or exclusive, until it commits. Only after the commit operation by transition T1, then another transition T2 will be able to apply for the locking. Otherwise, it will not be able to gain the lock. So, this protocol that I was telling and this protocol, they are used to avoid cascading failure. Now, there is another thing that we can also do is we can change a shared lock into exclusive lock or exclusive lock into a shared lock. So, that is known as lock conversion. So, lock conversion means we are converting one type of lock into other type of lock. Now there are two types of log conversion. One is update and second is downgrade. Update log means we are converting the shared log into exclusive log, and downgrade is we are converting exclusive log to the shared log. So this concept is quite useful when we face the situation when there is a longer duration transaction doing so many operations, and it is doing the write operation at the end, and another transaction want to read a particular value. So since T1 already have the log, so another transaction T2 will not be able to acquire the logs. So in certain situations we can use log conversion to avoid these problems. Next protocol is time stamping protocol. Now see, the two-phase locking is having the problem that it is not deadlock free. Entire locking protocol is not deadlock free. So there are certain problems with them that they are not deadlock free locking protocols, whether simple locking protocol, deadlock prone, or two-phase protocol, or second is poor utilization of the resource and lower concurrency, since other transactions are not being able to perform the operations, since only one transaction is holding the resource. So to overcome that problem came the concept of time stamping protocol, whereby each transaction is getting a particular unique timestamp value. Now that unique timestamp value is either implemented through the system clock or through the counter value. So every transaction has a timestamp value, and that is used to order the transactions. So let us see an example. Transaction T1 created at 2 o'clock would be an older than all the transaction which comes after it. Why? It is because it has been born earlier than the other transactions. So using the timestamp value, we can find out which transactions are younger and which transactions are lower, so that we can resolve the conflicts between the transactions when all the transactions are exiting in parallel. So every data item is giving a latest read value and write timestamp value. In addition to the unique timestamp value for particular transaction, each data item is also given a latest read timestamp value and the write timestamp value, which are the values when the last read and the write operations are done on that particular data items. So now the timestamp is denoted by TS, TI. Read timestamp is denoted like R timestamp X, and write timestamp is denoted by W timestamp. Now this is the responsibility of this protocol, so that the conflicting pair of tasks should be executed according to the timestamp value, so that even if there is a conflict, then these transactions should not be suffering from that particular problem. So the transaction can perform only two operations, either read operation or write operation. So suppose the transaction Ti want to perform the read operations, and the timestamp value is less than the write timestamp value. It means a younger transaction has already written the value of X, and Ti was too late in performing the read operation. So Ti will not be given the permission to read the X. Now second situation is, if the value of the timestamp Ti is greater than or equal to the write timestamp, means Ti is a younger transaction than the transaction that wrote the value of X. So it will be given the permission to write the value of x. And now since the write timestamp value will not change, only the read timestamp value is changed. So read timestamp value will be the value greater than the existing value of the read timestamp value and the timestamp value of the transition Ti. Now second scenario comes when transition Ti want to perform the read operations, write operation. Now we will be discussing the concept related to the write operation by transition Ti. Now first, if we are seeing that if the write timestamp, you see transition Ti has timestamp value and that is less than the write timestamp value, then Ti will not be given the permission because a younger transition has already read the value that was to be updated by this transition. So it is writing an obsolete write and cannot be given the permission to perform that particular operation. Now again, the timestamp value of Ti is less than the write timestamp value. Then what will happen is, again transition Ti will not be given the permission since a new transition has came in the system and already wrote the value of x. So again Ti was too late in performing the desired operations when it will not be given the permission. Next, if the value of Ts, if the value Tsi Ti is greater than or equal to the write timestamp value, then this transition want to perform the write operations, then it is a younger transition than the transition that wrote the value of x. So again this transition will not be given the permission because it is a younger transition. So a younger transition can very well write the value if its value is greater than the write timestamp value, means it is younger than the transition that wrote the value of x. Now the write operation will be successful and the write timestamp value will be set to the larger between the existing write timestamp value and the timestamp value of this transaction. So in a nutshell, the issue occurs whenever the older transitions is too late in performing the desired read or write operations. So this transition have to be in such a way that they are always younger transition. So it is not possible that every time a transition is younger transitions. So they are bound to roll back, and whenever the transition roll back, they shall be assigned a new timestamp value so that they do not face the same problem of being killed each and every time. I hope it is clear to all of you. That is all from today's lecture. Jai.